Hello friends, our today's topic is the last one, differential equation and its applications. So what is a differential equation? Equation involving dependent, independent, derivative of dependent and derivative of independent variable is called as differential equation. To understand the concept, let's have some example. These are the examples of differential equation. You can see derivative, second order derivative, under root sign. All these are examples of differential equation. In short, we call it as a DE. Now, how to decide order of a differential equation? So it is nothing but highest order derivative occurring in the differential equation. Then what is the degree of the differential equation? It is the power of the highest order derivative when all the derivatives are made free from fractional indices. This is important, as well as negative sign if any. So what we have learned, to find the degree of the differential equation, make all the derivatives free from the fractional indices and negative sign if any. Here is the first question, determine the order and degree. Now you can see d2x by dt square is the highest order derivative, order is 2, so therefore order of this equation is 2. And what is the index of this second order? That is nothing. Nothing means 1 is always there, so degree is 1. This is the second example. Now here again, don't concentrate on this 2 and 3, you have to concentrate on the higher order derivative, which is 4. So therefore 4 is the order and index is 1, so degree will be 1. Now for this equation, it contains radical sign, means under root sign. You have to make it free. 3 by 2 is also under root sign. So squaring on both sides will give you this type of equation. On solving, you will get this type of equation. Now dy by dx square, dy by dx bracket cube. So we have to consider this one. So dy by dx is of first order, order is 1 and its index means power is 3. So degree will be 3. This is the fourth example. Sixth root is given, taking 6 power on both sides. You have to consider this one. So order is 3 and degree is 1. I hope you got the concept of how to decide order and degree, which is of 2 marks only. Now how to form a differential equation? The process is by eliminating arbitrary constant. So if the order of a differential equation is n, then you have to differentiate the equation n times to eliminate the arbitrary constant. Means if it contains two constants, you have to differentiate twice. This is the first example. Y is equal to a e raised to 3x plus b e raised to minus 3x. Famous example. It contains two constant a as well as b. We have to eliminate them. To eliminate, you have to differentiate twice. So differentiating twice, obviously e raised to 3x derivative will be 3 into e raised to 3x and this minus 3 into b e raised to minus 3x. And the second order, 3 3s are 9, minus minus become plus. Taking 9 common, you can get again this equation is nothing but y. Replacing the value, you will get d2y by dx square is equal to 9y is the required differential equation. You can see arbitrary constant getting eliminated. This is the second example, c2 plus c1 upon x. You can see two constants are there. On solving, I will get xy is equal to c2x plus c1. Two constants, so differentiate twice. Now clearly there is a product. You have to apply product rule. X into dy by dx plus y dot 1. X derivative is 1 and c1 is a single constant without x, so derivative will be 0. Again differentiating. Again you have to apply product rule for this. X d2y by dx square plus dy by dx, derivative of x is 1. Again y derivative is dy by dx, c2 derivative is 0. Collecting the parts, you will get the answer of the differential equation. X d2y by dx square plus 2 dy by dx is equal to 0 is the required differential equation. So this is our second example. The third one is for you, c1 plus c2x e raised to x y equal to. Now here you have to make this equation free from e raised to x, so multiply by opposite, that is e raised to minus x on both sides. Now two constants, so differentiating, again product rule, e raised to minus x dy by dx minus y dot e raised to minus x, e raised to minus x is derivative e raised to minus x, and minus sign is also there. c1 derivative is 0, c2x derivative will be c2. Taking e raised to x minus common, again differentiating, so d2y by dx square minus dy by dx, and now e raised to minus x derivative is minus e raised to minus x dy by dx minus y, c2 derivative will be 0, again collecting d2y by dx square, this minus 2 dy by dx minus minus plus, e raised to minus x shifted on this side, you will get the equation d2y by dx square minus 2 dy by dx plus y equal to 0 is the required differential equation. The fourth example for you, c1 e raised to 3x plus c2 e raised to 2x. Now this is a different example. First we make e raised to 2x to be free, multiply on both sides by e raised to minus 2x and differentiate. Product rule is being used. You can see c1 e raised to x derivative, c1 e raised to x, c2 will become 0. Now e raised to x I want to make free, so multiply by minus e raised to x on both sides to each term. We will get up to this one, e raised to minus 3x is common, we get this one, differentiating. Actually here it should be c1. On differentiating, e raised to minus 3x d2y by dx square, again product rule is being used. E raised to minus 3x derivative is minus 3 e raised to minus 3x dy by dx minus 2y equal to 0. Then collecting the parts, e raised to minus 3x common and e raised to minus 3x is equated with 0. We get the answer d2y by dx square minus 5 dy by dx plus 6y is equal to 0 is the required differential equation. So these are the four examples how to form the differential equation. Now the next part is how to solve differential equation. Solution of a differential equation. The first method is variable separable. The name contains everything. You have to separate the variable x and y. So sometimes it is of the form fx dx plus gy dy is equal to 0, where fx and gy are functions of x and y. This is said to be variable separable form whose solution is obtained by integration of fx dx plus integration of gy dy is equal to c, where c is the constant of integration. Now there are two types of solution. One is general solution, one is particular solution. So solution of the differential equation in which the number of arbitrary constant is equal to order of differential equation is called as general solution. And a particular solution will be obtained from the general solution by giving particular values to the arbitrary constant is called as particular solution. So note this point. Now let's have some examples. Solve the following differential equation. The first example is in front of you. The solution is like this. I took y common, then y is shifted on the left hand side for the variable separable method, y to dy and all terms of dx with x. So this is the procedure. Now integrating. On integration of 1 upon y is log mod y, x square integration is x cube by 3, 1 integration is x plus c is the general solution. This is a short question. The second example is like this. I can take x square common, I can take y square common. So this is the format. Then divide by both term with the required term, means here keep the terms of y and here keep the terms of x. So divide by x square as well as y square. We will get 1 minus y upon y square dy and 1 plus x upon x square dx. Integrating, we came to this stage. Separating, 1 upon y square minus 1 upon y, and this is also separated like this. Actually, you have to take the LCM of this, divide by all the terms, you will get the answer. Means here divide by y square and divide by x square. The term which is not required you have to shift on in the denominator. Now integrating, we will get y raised to minus 2, here x raised to minus 2. Again integrating, integration of y raised to minus 2 will be y raised to minus 1 upon minus 1 log of mod y. Same thing here, collecting the terms which are like this. Again collection is done. So final answer log of mod x minus log of mod y is equal to 1 upon x plus 1 upon y plus c is the general solution of the problem. So note this problem, one of the nice question. Now you are asked to find particular solution in this category. This is one example. Now how to recognize the problem, whether it is of general solution or particular solution. In general solution, these particular values are not given. When these values are given, you are expected to find particular solution. Let's simplify. So I took x common, I took y common, same line. Now separating the variable, I have to divide here by 1 plus x square, sorry, divide by y and divide second term by x. So we came to this stage, x upon 1 plus x square, y upon 1 minus y square. On integrating, here I make one adjustment. We know derivative of x square is 2x, so 2 multiplied and here also 2 multiplied by 0 is 0. Integrating, so we came to this stage. Now this minus I took inside because 1 minus y square derivative is minus 2y. So we came to the stage log of 1 plus x square plus log of 1 minus y square. Already minus sign is given, and whenever both the terms containing log, you must take instead of c to be log c. This is the procedure. So addition means multiplication, log gets cancelled, and finally we came to the stage 1 plus x square into 1 minus y square is equal to c is the general solution. Now in this general solution, you have to calculate the value of c by putting x is equal to 2 and y is equal to 0. So I have replaced into this equation. I got the value of c to be 5. Again replace this value of c to the general solution. You will get the particular solution. So very simple. This is a 3 marks question. Note this. So step is repeated. Now the second question is y into 1 plus log x minus x log x when x is equal to e and y is equal to e square. So I have separated, then divide by x log x, separate the terms, integrating. So integration symbol is given. You can see numerator is a derivative of denominator. The type is f dash x upon f of x. So log of f of x is the answer. 1 upon y log y, again take log c. So we came to the stage x log x upon y is equal to log c. So x log x upon y is equal to c is the general solution. Replacing the values, x is equal to e as well as y is equal to e square. So we came to the stage e log e upon e square. Log e is 1, e gets cancelled, value of c is 1 upon e. Replacing the value, on cross multiplying you will get the answer ex log x is equal to y is the particular solution of the problem. So learn the problem, solve it yourself, you will get confidence. Now the next is homogeneous differential equation, one of the very nice type. So what is homogeneous differential equation? That is, all the terms are of the same degree. You can understood with the help of one example. You can see x cube power is 3, y cube power is 3. Here 0 means no problem. Here 2 plus 1 is 3. Here also 3. This is just example. So my point is order of x and y terms should be equal in each and every term. So these are called as homogeneous differential equation. Now the point is how to simplify them. So that is solution. So you have to substitute y is equal to vx in this case after recognizing it is a homogeneous DE. Then differentiating, you will get dy by dx is equal to v plus x dv by dx. Then this equation is converted into variable separable form, and you can solve it by using variable separable form. You have to substitute v is equal to y upon x. Let's have some examples. See here, y square is 2, 1 plus 1 is 2, here also 2. So this is nothing but homogeneous differential equation. In the examination, it is not said solve the following homogeneous differential equation. Friends, you have to recognize whether it is a homogeneous or regular sum. So I have separated by dy by dx. After shifting the terms, we came to this stage. Now clearly y square, here 1 plus 1 2, here already 2, so this is a homogeneous differential equation. To solve it, you have to substitute v upon x. Differentiating, you will get dy by dx is equal to v plus x into dv by dx. So replacing v plus x dv by dx, y value to be vx, so v square x square, y value to be vx, x square you can see common everywhere, gets cancelled. Then I have to shift this v on this side to make it variable separable, perform the calculation. We came to this stage. Again solving, you will come to this stage. Then variable separable, this term goes to numerator, this to denominator, x comes to this side, minus sign remains as it is, integrating on both sides. So we came to this stage. Now here I took v common and it will be like this form. So we came to this stage again. So there is a one adjustment, 2v plus 1 minus v. I would like to go back. So here v plus 1 is made 2v, 1v is increased and 1v is subtracted. So we came to this stage. Now separating the things, first thing you will get 1 upon v, second thing you will get 1 upon 2v plus 1, remaining things as usual. Now integration of this is log v and integration is log of 2v plus 1. Note one point, 2v is a composite, derivative of 2v is 2, so it should be divided. And this is minus log x plus log of c1. Applying the rules of log, we came to this stage, 2 is multiplied, it become 2 log c1. So it will become log of v square, log of x square and log of c1 square. Minus means division, here plus means here this is minus, so upon x square, log cancelled. We came to this stage. Now replacing value of y to be y upon x, so we came to this stage. So after simplifying, y square upon x to y plus x, c1 square upon x square, multiply 1x gets cancelled, xy square is equal to c1 square x plus 2y. I changed the order. Now c1 square we will replace by another constant c. So this is the answer of the problem, is the general solution. This is a 4-mark question, note the point. Second question for you, again you can see 2, 2, 1 plus 1, 2 and 2. Clearly it is a homogeneous differential equation. I have separated the variable, divide by x square. So remaining thing as usual according to previous problem, replacing the values, dy by dx, 1 y upon x is y value is vx, v square x square, 1x gets cancelled, x square gets cancelled. We came to this stage, this v and this v also gets cancelled. We came to this stage. Now separating the things, integrating. Now 1 minus v square dx upon 1 minus x square, or you may say dx upon a square minus x square. The formula is 1 by 2a log of 1 plus x upon 1 minus x. So same thing I have applied, a value is 1, so 2 into 1 will be 1, log of 1 plus v, this side log x plus log c1. Then replacing the value of y, x plus y upon x minus y, and 2 is shifted, so it becomes c1 square x square, log cancelled. We came to this stage. Now c1 square is replaced by c again, x plus y upon x minus y is equal to cx square, is the general solution of this problem. So this is also one of the very nice question. So thank you very much friends for attending this session.